choosing batch size in presence of setup time. Suppose I choose a batch size of 200 for my milling machine. In this case, I will be having a capacity, remember, batch size divided by total time of setup and production, which will be 200 over 120 minutes of setup time and 200 times 2 minutes of production time. The capacity will be 0.3846 units per minute. Well, if scooter assembly line produces one scooter every 3 minutes, so the flow rate is 1/3 of units per minute, right? What will be the inventory of ribs and steel support? So here we are actually evaluating more accurately the inventory of ribs, the bolt line, and the steer support, the thinner line. The thing to remember is that we're assuming that the assembly line continuously works, and so it continuously picks up one set of parts, right? One rib and one steer support and two ribs that are sufficient for each one scooter once every 3 minutes, right? So it consumes parts at this rate, right? And we can produce on average at this rate, which is higher, right? So milling machine has a capacity higher than the assembly process flow rate, right? So let's see how this is going to work. So remember, when we're starting producing the ribs, right? This is, let's say we've already done the setup and we're producing. We should aim to have, the beginning very low inventory of ribs. At this moment, we will be producing, but remember, because we are running the assembly line, this increase here is the net increase of producing and consuming at the same time. The consumption is due to the assembly line operating. So the assembly line consumes the units and we're producing. So if you produce the batch of 200, during this production of 200, you will actually use 66.6 or 67 roughly units. So the maximum you should reach will be 133, right? That's 200 minus what is produced during 200, what is consumed during 200 minutes will be roughly 67 of the ribs, right? Or pairs of ribs. And then remember, we should have the inventory from the previous batch of the steer support. This is in a steady state, right? And of course, we are also consuming the steer supports, which are not produced during these 200 minutes. Then we have a setup for the ribs. The setup will take 60 minutes, right? During this setup already, the ribs are consumed. And then when we produce the ribs, the steer supports, the ribs are being consumed, and again, the steer support is produced and consumed at the same time. So the consumption is continuous, right? It's because assembly line is continuously operating, right? But the batch productions shifts from one product to the other. So after 200 minutes producing steer supports, again, there will be a setup. And then what happens is that in order not to build up inventory, we have to wait for 80 minutes doing nothing. This machine has to take a break and before it starts the next cycle. Why is this 80 minutes necessary? Well, because there is a mismatch. The capacity of the milling machine is higher than the flow rate and the consumption rate at which the assembly line consumes the parts, right? So due to this mismatch, there is some idle time here, 80 minutes every 600 minutes, right? So we actually could reduce the batch size because then this inventory would be smaller, right? And we said avoiding large inventory is a good idea for many reasons, right? But if we reduce it too much, the capacity may drop such that it will limit the production rate at the assembly line, and we don't want to create this, but because this would create a bottleneck, the milling machine would become a bottleneck. Currently, in this with batch size 200, it's the assembly line that is a bottleneck, or somewhere in the assembly line there is a bottleneck. So I hope you see that we need this as a balancing act. The batch size should be reduced, but reduced not too much. So what is the right batch size? It's very easy to see that we have to kind of create a balance by making the milling machine capacity equal to the assembly line flow rate, right? So the process, right, we will draw now, it looks like this. There is the milling machine, some inventory of parts, and then the assembly process. Remember, assembly process now hides the detailed process flow diagram that we had before for the assembly line, right, with 3 stations and so on. And all we know is now there's a time per unit. There's no setup on the assembly line. This is running in a different mode. Here there is setup 122 minutes, 2 minutes per unit, as we said. And right, with these batch sizes, we calculated some very small capacity, very large capacity for a very large batch size. And we said, well, now we want to match flow rate, match the capacity of the milling machine, which is batch size over setup plus processing of the batch, match it to the flow rate of the assembly line. Flow rate of the assembly line is 1/3. I'm skipping the units here. And the calculation of the capacity is batch size divided by 122 minutes plus batch times 2 minutes. So if you solve this, you will find out, right, it's actually quite easy to calculate that, that the optimal batch, or so the batch size that makes those two numbers match is batch size 120. With this batch size, the milling machine will be producing at exactly the rate of assembly line process. So it will be producing at exactly one set of parts every 3 minutes. So it will reduce the inventory that we saw on the previous slide. It will be smaller because the batch size 120 will not build up so much inventory for either of the two products, right? Graphically, if you remember, we said this pink line is the capacity of the milling machine as we increase the batch size. So what we did is we said, oh, but the capacity of the assembly line is this. It's 0.333, right? 1/3, 1 unit every 3 minutes. So we tried to find the batch size that will match the capacity of the milling machine, the batch process, to the capacity of the assembly line. And we found out this is when batch size is equal 120. And we would say, right, if it's too small, then the milling machine becomes a bottleneck and it slows down the whole process. This is extremely undesirable because that means we are not selling, we're not matching the demand. We're probably leaving a lot of revenue, potential revenue, not collected. And if the batch size is larger, this is not that bad, but it still creates unnecessary inventory. So too large batch size, we should avoid